All right, so we're going to do a couple of actual AP questions from the past. It tells you what year they were and what they did, and you're going to see some like this on the AP test. They're not going to be just like this, but similar. So this one is from 2010. It was both on the AB and BC because all of the AB stuff you do again in BC. And if we look here, it says a zoo sponsored a one-day contest to name a baby elephant. Zoo visitors deposited entries in a special box from noon, that's when t equals 0 is at noon, to 8 p.m., that's when t is 8, because the noon date is 8 hours. The number of entries in the box t hours after noon is modeled by the differential function e. If you look up here, there's e. And for 0 to 8, and this says by a differential function, which I would say then e is, you should write e is continuous because from 0 to 8, because we may need that on something else. Because e is differentiable from 0 to 8. Okay? So you should write that down there. It tells you something's differentiable. The values of e of t in the hundreds, now that's a key there. You got hundreds. So in our answer, we're going to have to write the word hundreds down. Of entries at a various time t are shown in the table. So at time 0, there were 0 hundred. At time 2, there were 400. Notice it's hundreds. Time 5, there were 1,300 ballots, okay? So we're supposed to use the table and the data to approximate the rate. Now that means the derivative. The rate means the derivative. And hundreds of entries per hour. And it's even telling you how the label goes. At which entries were being deposited at t equals 6. So we look up here. Where's t6? Well, 6 isn't up here, right? So we have to use the two that are closest, and since it's a derivative, that means we're looking for the slope. So we would say e prime of 6, because the derivative is the slope at these two places, is approximately, we put 21 minus 13 all over 7 minus 5. If you want to put hundreds of entries per hour, you can, because that's what these are. I'm going to label that in the end. I guess we actually could put hundreds of entries per hour, and that would be the answer without doing any work, but I'm going to go ahead and simplify these. So this is 8 over 2, which is 400 entries per hour. Okay, so that would be the answer we're looking for. And again, you don't have to do any of the math. You could have put this fraction and put hundreds of entries per hour and have it perfect. Use the trapezoidal sum theorem. All right, so we're going to use trapezoidal sum, and we want 4 intervals. So I've already drawn the picture to save time. I put all these points down, 0, 2, 5, 7, and 8. I put all their heights over here. Now they're not accurate, but I don't really care. And I'm going to get this these trapezoids. So I know this first point is 0. At 2, I'm at 4, so this height is 4. At 5, the height is 13. At 7, the height is 21, and at 8, the height is 23. And then I got to get these distances here. So 0 to 2 is 2, from 2 to 5 is 3, from 5 to 7 is 2, and from 7 to 8 is 1. So if you remember, the parallel sides are the bases. So these things going vertically are the bases, because they're all parallel. So I'm going to start over here to the left and do base 1. Now it's actually a triangle, so you don't have to, you could do a triangle for this, but I'm going to say 0 plus 4 are my bases. The height is the distance between your x's. So 0 plus 4 times 2 all over 2. And I probably should have written this down too. So I'm going to try to squeeze that in there. 1 over 8 integral 0 to 8 e of t dt. I should have had that in there. That's my bad. And then we do the next trapezoid, which base 1 is 4, base 2 is 13. Okay, the height between these two, 2 to 5 is 3. And we're going to divide that by 2. And then the next trapezoid is 13 and 21 are the bases. And the height between 5 and 7 is 2. And we're going to divide that by 2. And plus the last two bases are 21 and 23. And the height between 7 and 8 is 1. And we put that over 2. And that's my answer right there. Now, if you want to simplify this, I'm gonna put this down. I'm not gonna type it in. I haven't typed it in my calculator, so I'm gonna get the actual answer off the sheet because I don't want to spend the time doing this because the videos go too long when I do that. Okay, so this whole thing comes out to be, okay, when you round this thing out, oh, something I forgot to do. I left the 1/8 off, right? There's a 1/8 in front. So this whole thing is multiplied. I'm going to stick it out here by 1/8. I hope you remember that since this is 0 to 8, that this 1/8 minus 0, this is the average because we're dividing by the 8 minus 0, b minus a part. So this is the average value theorem. But we're doing trapezoids. So if you simplify this thing, it comes out to be 171/16 without a calculator. Okay, if you use your calculator, which just says up here we can, this was a calculator problem, it would have been 10, and we got to have 3 decimals, 6.88, and we would say hundreds. Remember, this is the area, right? So it's this times this, which is hundreds of entries, but remember we have this 8 in front. So this 8 in front is actually over 8 hours, right? At 1/8, or this 8 down here, this is hours, so it's hundreds of entries per hour, okay? So this is the average amount of entries, because of the 1/8 makes it an average. Average amount of entries is approximately 10.688 hundreds of entries per hour from t equals 0 to t equals 8 hours is how you would write that answer. Okay, so that's a pretty tough problem. Now, if you wanted to answer this better, or maybe not, I don't know, but remember we got hundreds here. So we would probably want to bring this on out further, but you could move this decimal place over and say about 1,069 entries per hour was the average from 0 to 8. So there's some stuff you have to think about when you're doing these problems. Okay, so this problem says at 8 p.m. volunteers begin to process the entries. So what that means is they're taking them out and they're starting to count them. The processed entries are at a rate modeled by this function right here, and I already typed this in my calculator, hundreds of entries per hour. So this is how fast they're counting the votes. They're seeing what names they've got and counting them. According to how many entries, according to the model, how many entries had not been processed by midnight. Now, if you notice, this is from 8 to 12 right here, which if you go back up here, remember we started at noon. At noon, t was 0, 8 p.m. was 8. And so this is going from 8 p.m. to midnight. So if you look, at 8 p.m., the zoo closed, we had 2,300 entries total. So this stands for the 2,300 minus the part we're processing. So it's going to be 2,300 minus this thing, which P of T is this processing. So I'm going to get my calculator and stick it on there and show you how to do that part. So let me get my calculator here. Type this in, so I'm going to show you. So if you look here, I've got that equal sign highlighted right there, which means that one's on. This one's for the next problem, so it's turned off. It's not using that one, so I'm doing this one. So that's the object I'm looking for. So I'm going to do the integral. So I'm going to hit second quit and go here. I'm going to hit math 8. Oh, that's derivative. Let's go math 9 and do integral, my bad. And we're going 8 to 12. And we're doing y sub 1, so I'm going to hit bars, y bars, 1, 1, with respect to x. So I'm going to hit enter, and there's my 1,600. So that value comes out to be 1,600. Now, they could do this problem without having a calculator. So we would say minus 16. We should probably put hundreds of ballots. Okay, hundreds of ballots, or hundreds of, I should say hundreds of entries. And that can be your answer right there, or you can go ahead and subtract those, and you can say 7 And you can write the word hundreds of entries, or you can even put 700 entries is what that stands for. So what this means is at the time midnight, from 8 to midnight, after they were done at 8 to midnight, there were 700 entries left. So this is a rate in, rate out problem, in case you didn't know. This ballots, these are the ballots going in. This is the rate in. This is the process. This is stuff coming out. So this is the in part. We've done this before, and this is the out part. So in minus out gives you how many are left. So at midnight, there would be 700 entries left to count, is what that basically means. According to the model from Part C, at what time were the entries being processed the most quickly? Okay, well, this is processed. Most quickly, I already wrote up here, means the max. We want the max of just processed. So to get maximums, I hope you remember, we have to set the derivative of this thing equal to 0. And this says according to Part C. If you remember, Part C is saying from 8 to 12. Now that's going to be important on my graph. So I'm going to do the derivative of this function, and I got to type that into my calculator because I have not done that yet. But I'm going to show you a shortcut because I already typed in the other part into y1. So I'm going to hit y equals, and I'm going to come way down here. I'm going to turn this one off because I don't want p. I want p prime, and I'm going to type p prime in right there. So I'm going to hit math 8 right here, math 8. So this is the derivative. I'm taking the derivative of that y1, so I'm going to hit vars, y bars 1. Then I'm going to come over here and put x equals x so it will graph it. Now on my window, if you remember, the only thing I'm worried about is from 8 to 12. That's the part in that problem we're worried about. Okay, so I'm going to graph this. I may have to change my y around. Not sure yet, but we're going to graph it and see what happens. And this is going to be the graph of the derivative from 0 to 8. And then when you type in derivative, they go slow. So I got a quadratic here, it looks like. So what I got to do is I got to find the zeros, because remember, zeros are critical numbers. So I'm going to hit second calc 2. I'm going to come over here. I'm going to hit enter and go to the other side and hit enter a third time. And so that's at that decimal number, x is one of the zeros. Remember, critical numbers occur where the derivative equals 0. So I'm going to use that, and I'm going to save that. So I'm going to hit second quit, and I'm going to hit second answer, and I'm going to store that answer in A. That's A. So there's that number in A. Then I'm going to go back to my graph. I'm going to hit second calc, and I'm going to get that other 0 over there. So I hit 2 for 0, and I'm going to come over here and get this 0 because it's also a critical number. So I'm going to hit enter, go on the other side, hit enter, enter, and that 0 is that 10.816 there at the bottom of my calculator. Hope you can all see that. And then I'm going to hit second quit, and I'm going to store that one. I'm going to hit second negative, which is answer, and I'm going to store that in B, alpha B. Okay, so those are my 2 critical numbers for P prime. Okay, so what I'm going to do now is I'm going to get out of my calculator for a couple of minutes here. I'm going to make a T-chart because I want the absolute maximum being processed. So my critical numbers occurred at P of P prime of x equals 0 at 9.1835 ... I'm not rounding that answer yet, and also at 10.81649, 10.81649 ... And if you remember, absolute max and mins can also include the endpoints. So we must include the endpoints to those 2 things, because those can be the critical numbers. So we're going to make a T-chart, and this is going to be the justification of my answer. So I'm going to put T for time, and I'm going to put P of T, and I'm going to plug in at 8, because remember, this is from 8, we're talking about from 8 to midnight. That's one endpoint. Then I'm going to put 1 critical point down, 9.183, and I'm going to put ... because I'm not rounding that, and 10.816 ... because I'm not rounding that. And then I'm going to put my other endpoint 12 in there, and I'm going to plug that into this part. So I've got my calculator right here, and I'm going to use my calculator to get those answers. So here's what I do. I go back to my graph. Only thing is, I go back to y equals, and I want to plug them into my original P of t. That's what I'm looking for. So I'm going to turn that one on and come down here and turn the derivative off. And here comes my P of t. So you should be able to tell from this that this point out here at 12 is going to be the highest point, but we don't care. So I'm going to hit second, calc 1. And my first value is 8. So I'm going to hit 8. I'm going to look at that. That says at 8 there were 0 processed. So I'm going to come back over here to my chart. I could save those if I wanted, but I'm not going to. I'm going to put 0 here. That's that process. Then I'm going to hit second. Oops, let me get the calculator back up there. Second. I'm going to hit second, calc 1 again, and I want to put that first critical number, which I saved at A. So I'm going to hit alpha math, and that plugs A in. So that is 5.0886, 5.806. So I'm going to write that number down here, 5.08866, blah, blah, blah. I'm going to do the next one, so I'm going to hit, again, I'm going to get my camera up here. I think I'm going to go ahead and, no, I can't. So I'm going to hit second, calc 1 again. I'm going to hit alpha apps, which is B, hit enter. So that number is 2.91133, blah, blah, blah. So I'm going to put that one right here, which is 2.9113, blah, blah, blah. And then I'm going to type 12 in. So going back to my calculator, I'm going to hit second, calc 1, type in 12, and I get out 8. 8. So I hope you can see this is my max. So this says, according to the model of Part C entries processed, at what time were the entries processed the most quickly? So I would say entries were processed at 800, or you can write down 800 entries were processed, I should say here, the fastest or the most, equal to 800 at t equals 12 hours, or you might say at midnight, however you would like to say that, but that would be when, this is the thing we're looking for, the when part. They're most quickly processed at 12 hours. Okay, going on to the last problem on these, and again, I typed some stuff in to save me some time so the video wouldn't be so long. It says, there's snow on Janet's driveway. Oh, this is a few weeks ago. When snow begins to fall at midnight, from midnight to 9 a.m., snow accumulates. So accumulation, that is the N, or the positive one, right? Accumulating snow's coming in on the driveway at a rate modeled by this function. So that's the other equation I already typed in, at cubic feet per hour. Now this means this is already a derivative. Cubic feet per hour is how fast the snow's coming. And it's since midnight. So what that means is, at midnight is t equals 0 times 0, because it also tells you 6 a.m. is 6. Then Janet starts removing the snow. So removing at G of t. So this is the out part. This piecewise is the out part. This is the minus part. She starts taking it out at 6, gets up and goes out and starts shoveling her driveway or whatever. She's got a snowblower or whatever. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? So again, we started at midnight, which is t equals 0, because 6 a.m. is 6. So we want to do the integral of f of t dt. And again, this is calculator, so I'm going to use my calculator to do my integral because it's faster. So I'm going to go to my y equals here, and I'm going to turn this one off. I'm going to come down here because this is the function I want. I'm going to turn that one on. I'm going to hit second quit. Now that's in y2, so I'm going to hit math 9. And I'm doing from midnight, which was 0 to 6 a.m. And I'm doing bars, y bars 1, but now I got to hit 2 for y2 dx. So this is the snow coming down. So from midnight to 6 a.m. we had a, holy smokes, it's a lot of snow. We had 100 and I got to go back and look at the problem, but oh, this is on our whole driveway. That makes me feel better. We have approximately 142.275 cubic feet of snow has fallen on the entire driveway. That's a lot of snow. We want to find the rate of change of the volume of the snow in the driveway. So again, this is cubic feet. We want to find the rate of change of the volume. So this is the derivative rate of change of the volume of snow in the driveway by 8 a.m. So what that means is this is the accumulation of snow at 8. This is the taking the snow away at 8. So I'm going to do these two things. So I'm going to look up here. The taking away is right here in my chart. That's 108 cubic feet. So I'm going to subtract that 108 from this chart because the time from 7 to 9 and 8's right in the middle. That's 108. And I'm going to subtract that, and I need to do f of 8. So to do f of 8, I've got to do plug 8 into this function. So I'm going to do that on my calculator again. Okay, so I'm going to go back to actually I'm going to graph this. Nope, I'm going to stop this graph because I got to change my window. So we're talking about now we're going from 0 to 8. Midnight was 0, we're going to 8. Okay, so I'm going to go ahead and graph that. That goes up my graph, so I'm going to stop it and go a little higher. So I'm going to make my y value. I'm going to go my y value from, I need 0 to 8. And I'm just going to go from -1, even though there's no negative snow on there. I'm going to go up to, I don't know, 40. That may not be enough, but we're going to graph and see what that looks like. And again, this is cubic feet on the whole, on the whole drive. So my window is going to be bigger than that. So I'm going to go up to 100. Hopefully that'll be enough. I don't know. It's still going off my graph, but I'm going to see if it'll calculate it. So I'm going to hit second. Ooh, maybe I should trace it again. But I'm going to hit second calc. Second calc. And I want the value of this function at 8. So I'm going to hit 8 in there. And that comes out to be 48.41732. 48.417. I'm going to put 417 ... And then when I subtract those, I'm going to round it to 3 places. So it is approximately -59.583 cubic feet of snow per hour. And again, remember, these are already given to us, and that tells you right up here, removing the snow at a rate in cubic feet per hour. So you see how that's G of t is cubic feet per hour and F of t is cubic feet per hour. So I'm not doing integral or derivative, so this is still cubic feet per hour. Okay, going on down here, we got 2 left to do. We got C and D. And C says, let H represent the total amount of snow in cubic feet that Janet has removed from the driveway at the time midnight. So this is her snow being removed. Okay, so we're really only worried about this part. Okay, so we're worried about, I put H of t, but we actually want H of 0. Okay, and remember, this only works from 0 to 6, so that's why I put 0 to 6 here. So we got how much she's removed at time 0, plus we got an integral from 0 to some time t. Now see, this t can be anywhere from 0 to 6. I can put any value up here at the top from 0 to 6, but we don't know what time we're going to use yet. So we're just going to leave it a t, okay? So don't get freaked out by that. So that's some t, and remember this is g right here, but we're doing h, so this is a g of t, okay? So we're going to leave g of t there. actually, I probably shouldn't use that same variable because we're using a t there. So let's call this a different variable. I don't know. Let's call it r. It doesn't really matter. And then we're going to do dr. Okay. Now, how much snow did it say we're removing during this time? Do you see all that? It says 0 during that 6-hour time from midnight to 6 a.m. So this whole thing is 0. If you want to say that that's 0 plus this is 0 equals 0, that's fine also. But both of these are 0 because it tells me right there she took 0 away at that time. Now this part is only worried about from 6 to 7. So we're doing h of 6. Well, 6, it's equal to 6 right here. But at times 6, we had taken how much away? I hope we all see that we've taken 0 away. So this is going to be 0 because that's what we're talking about up here. Okay, it's 0. And I see that I should have taken that equal sign there and put it there, but it doesn't matter. It's still 0 at this time. And then we're going to do the integral from here. Now, what's the bottom part I'm worried about? We've already taken care of 0 to t here, right? This starts at 6. So we got to put a 6 down here to sometime t because we're not saying a specific time from 6 to 7. We're just saying from 6 to 7, and we're going to call this g of r dr again. It doesn't matter what variable we use here, but because we're using t out here, we're not supposed to use that t here. I don't think they'd count off if you did. But anyway, h of 6 again is 0 plus, and we want the integral from sometimes 6 to t, which means this part right here is going to be the, this amount is the amount we're talking about. So that's the amount that we're taking off right there. Remember, that's cubic feet per hour, right? Cubic feet per hour. So what that means is that is going to be, I guess I'm going to have to move this over. Thought I'd have room, but I didn't. So that is going to be 125. And remember, when you do an integral, it's the top minus the bottom. So it's t minus 6. So in other words, the entire amount we're going to move, 0 plus this thing, is just that thing from 6 to 7 is this. So the only t values you can put in here are anywhere from 6 to 7. So see, if you put 6 in there, you get 0. You didn't move any at 6. And now we got this same deal right down here we got to do. Well, at time 7, we have moved 125 cubic feet. So this thing right here is going to be the 125 that's in that problem right up here, this part. And then it's going to be plus the integral, and now we're starting at 7, and we're going to some time that we don't know for sure, but that could be up to 9, but we don't know what number we're putting in here of g of r dr. Okay, and I'm going to move this over so I got room over here. So this is the 125 is this thing, and I get that from this number right up here. During 6 to 7, they're taking that much out. Plus, and then again, we're removing that much cubic feet, which is going to be my slope, right? Rate, that's the slope. And then if you take the top one minus the bottom one. So these are the 3 different deals you're dealing with on this function to find h. So what that means is h of t is going to equal that 0, and that 0 works from 0 to 6. So we come over here and say from 0 less than or equal to t, less than, and looking up here, there's only a less than, so I should not have had that equal sign there. It should be down here. And then this is the amount right here from 6 to 7. So we're going to put 125 times t minus 6. If you want to distribute it, you can. And that's going to work from 6 to 7. And then the last one is going to be this part right here. And again, if you want to distribute and simplify this, you can, but I'm not going to. This is going to be 125 plus 108 times t minus 7. And then that last one is from 7 less than or equal to t less than or equal to 9. That is a pretty hard problem. And then we got the last thing. How many cubic feet of snow are on the driveway at 9 a.m.? Okay, do you remember we started at midnight, right? So t equals 12. I'm sorry, t equals 0 is midnight. So at 9 a.m., that's going to be T equals 9. So we are talking about to get just the total cubic feet of snow. How many cubic feet of snow? You got to do an integral of this cubic feet per hour. So when we do the integral of the snow, this is the snow coming on, this is the snow coming off. Okay, so snow on minus snow off is what we're looking at right here. So we are going to do, again, the integral from 0 to 9 of f of t. So I'm going to get my calculator out again. And I'm going to do, got to look here and again, okay, so it's y2 again. So we're using the y2 function for snow in. So we're going to hit second quick, and I'm going to do math 9. And we are going from 0 to 9 of y2. So I hit bars, y bars. It is a function. Hit number 2, dx. So this is going to be the amount of snow that went from midnight to 9. So how many cubic feet? So this is going to be 367.3346 ... and then minus h of 9. Well, do you remember that this is the function we're using when t is 9 right here? So that means this is going to be minus, I'm going to subtract this thing and plug 9 in for there because we want to know when t is 9. So this is going to be minus, we're going to put 125 plus 108. And since we said t was 9, we got to stick 9 in there for that. And this is going to be the amount of snow she took off. Okay? So she took that amount of snow off. And this is going to equal approximately 26.335, if you do it on your calculator, cubic feet of snow is how much will be left. This minus this gives you how much cubic feet of snow is left at t equals 9, or you could say at 9 a.m. So the applied problems are pretty hard. Please practice them. We're going to have a whole lot of practice after we get done when we start reviewing. I hope you have a good day. I'll see you tomorrow.